There we go. This is on the air live. Okay, so we're only, 17 minutes late. No big deal. All right, so tonight we were supposed to cover chapters 20, what, 3? No, it was through 23. 18 to 20, yeah, 23. And the first two parts were still in the previous section, which was on like, production applications. And then the rest was on streaming. And I think the streaming stuff is probably the more interesting thing to talk about, but the monitoring and debugging is probably the more pertinent thing to talk about, the relevant thing to talk about. So it says, there's a bunch of different ways you can monitor this stuff. And there is a configurable metrics system based on the Drop Wizard metrics library, which I had never even heard of. Have you used that at all, Dustin?
Kind of, yes. I have used it in Spark only. I don't know where it came from, but yes, I've used it in Spark. What I haven't done is stand up a full-blown like tool on the other side. Like I've done it with Ganglia, which kind of comes with AWS EMR. And so it's basically collecting some metrics there by default. So it's typical Spark setup where if you're just using standalone Spark, you're going to be tweaking some config files, basically either put them in the certain spot, or when you start up your Spark job, you tell it where to read the metrics config from. And that gets you the first starting point of it all. But I think if you plug it into like Datadog or some people like Prometheus, which isn't exactly integrated, then it's supposed to give you a better view into it without as much manual work, my understanding.
All right.
I'll learn more about that soon.
And so it talks about the Spark logs and the Spark UI. And so, but there was one part that I underlined here, like how you find the logs. I thought it was interesting that the typical way you find the logs is through the UI. You can what?
You can cluster.
Oh, cluster.
Yeah,
I have a.
Yeah, it's a little easier.
Put on Spark UI. Wait, why is my cluster stopped? That was weird. Hold on 1 second.
Have you used it recently?
I used it very recently, but I even set one more up, which is why. There we go. But it says it is in an error state. Cloud provider limit was encountered.
So it's probably the instance type you're using.
So I've requested more instances than my current instance limit allows. No, it's not a huge cluster. That's what's weird. I think it's just that I've launched it multiple times.
Probably change the EC2 type. You said
it. I mean, it doesn't let me set it. It's driver. It's community optimized. It says connecting.
Yeah. Did you like have one spinning down when you tried to spin this up?
I did. It spent one down for me, and then I had let it pause for 2 hours, and it automatically shuts one down. and I tried to start another, and that's where I am, and that's where I'm now. Yeah, so it's like, where do I, this also, I don't see a like start or a go or a make it happen. I can edit, I can
I
clone.
think where it says. Let me pull up.
Because it hasn't connected yet, you're saying?
Yeah, it's like,
I think that something's not showing right now because it's trying to.
yeah.
I think it was trying to pull one up. Remember what it was.
So if I refresh this, which I think I have, they're both showing the same thing, which is nothing. Okay,
Oh,
it says,
it's like-
okay, so it's like gone now. Okay, and so if I say create cluster, and I give it a name of Spark Demo UI, and I say create cluster. Okay, pin. But I don't know if it's going to work, because if it's complaining about the number of instances, then
So is this tied into your AWS account?
no, this is, I'm just using the community.
Edition.
Yeah.
Look, there's a cluster.
It's weird. So this Spark UI here, we're not even able to connect to the cluster, so we can't see the Spark UI.
Correct.
Oops, not available. Yeah. But if I go back, hopefully when this thing spins up, we
Yeah.
can get a Spark UI. Otherwise, I'm going to have to get a, I'm sorry,
Remove the previous one. On the left.
So
I can remove it. Like, okay. But it's still spinning this one up. Yeah, it normally takes a couple minutes, I have found.
So yeah, between Spark UI and driver logs. Pretty good way to look at
These are the two things that you most commonly refer to when,
it. I most commonly use the logs from, usually the logs are being shipped to HDFS. And so I will read them from there.
mm,
So if you run it, so when I was doing AWS on EMR, the logs go to HDFS on the cluster and they go to S3. And so I'd pick one of those spots and go look at the logs, which is not as good as having the logs going to something like Splunk or having a bunch of metrics set up.
I have a question. Can you use Spark to query over the logs? Can you use Spark to query Spark logs? Can you say,
Sure, you could, yeah.
yeah,
Yeah. I don't remember what the format is, how painful it is, but yeah, they're logs, so you can.
okay. It's up.
Oh, it's spun up. Good.
Yeah, that is good.
Alright.
Okay.
So you got the UI, but there's nothing to see.
Yeah,
Run on this
right. But I previously, let's see. So if I go to data, was it this one? Yeah, this one. Yeah. Okay. This was the one that they had us try. Yeah, retail data. Yeah. Okay. So, and I had a notebook related to this. Where's my notebooks?
Oh yeah, actually the home page.
Okay, so chapter 18, that's what we're doing. Okay. And then if I control enter this, attach and run. Okay. Okay, so it went through 7 stages. And then if I go back to clusters and to my Spark UI, there we go. There's my completed jobs, the 3 stages. Okay. And this is where the sequel doesn't look as interesting to me. As it looked in the book.
What, the explain plan?
Yeah,
Or-
this thing in the book, it looked like you could drill into a step and see some information. I guess, is it because I have so many steps that it can't show it graphically? Is that why?
Why do you have some-
It's a very good question. That's a lot of steps for such a simple. I mean, the query on the previous page is like,
Yeah.
well, it did a repartition, a select, a group, a count, select.
Just showing the same things without a cross.
Yeah. Yeah, so SQL 2DF collect, SQL 2DF collect. Yeah. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, etc.
So go to the stages tab,
Stages.
and then click
No.
on, let's see.
They said go to
Oh, no.
SQL. That's where it should have been.
Oh, yeah. Okay. So
But-
click on one of those, but it wasn't interesting, you said?
Well, you can click
Try
on
the-
this. Oh, there it is.
Yeah,
Okay.
yeah.
Oh, I see. Okay. I get it.
There's also like the DAG view, which allows me to show you, but I always lose track of where it's
Wouldn't that be in the job or the
I think it's
stages
under job, but yeah.
event timeline? Nope.
Yeah, SQL is what they're showing.
No. I don't see anything else. I don't see a.
What are you trying to do, Scott?
Well, Dustin was saying if you can, there's a DAG, you can see a visual representation of the DAG.
So from jobs, click on the one of the under description. Click on one of those. And there's the DAG visualization.
Cool. Cool. So again, this was repartition. So that would be an exchange. And then this would be the select map. Yeah, I guess. And then shit, that's stage 6. I mean, poop. How do I get back? Okay, yeah. Okay, and then you have a group by and account. I don't know. I can't decide if that's useful or not.
Yeah, I agree. So the part where it shows, like at the very first part of JAWS, where it shows the number of stages run, what succeeded, and what is so like all the way
Yeah.
to the right. Like that's useful when it's running, and it's
Mhm.
useful if it breaks. But really, when it breaks, the error message is the most useful.
I see.
That's not always the easiest to get to, but it's definitely in the log.
Yeah. Cool.
So what's in the metrics tab? Oh, it's a bunch of files. Okay. Yeah, click on one of those metric. Go to the metrics tab up. It's up at the top level of tab.
Okay. Mm-hmm.
And then, oh, so yeah, so Ganglia's, yeah, so that's a fully connected way to look at metrics. Making enough sense of them to change what you're doing is a different story. But
You know what? I can almost tell this is written in R. You know what I mean? Like, look at the graphics. It looks so R-like. It's weird. What?
It's not all right.
It is. It
The
is.
way I talked to one guy who worked with Spark and with Spark R, and he told me a couple of years ago that it's still interesting. And I tried to do something with Spark here, and they did not move much.
They did not what
Spark.
much?
They did not move much.
Spark, she's talking about Spark.
Yeah,
is
yeah.
not
Spark
super,
R. But this UI, you have to admit, looks R-like. This ganglia,
The output.
I'm saying the ganglia output looks
is
like it was produced using not PyPlot, you know.
ggplot.
Yeah, ggplot or whatever. Yeah. It looks just like that.
I know why you're saying it, but it's not exactly like.
Anyway. To me, it reminds me of
So
that.
then you didn't have, okay, so I had actually some metrics files, but it's really just snapshots of Ganglia. So not anything different than what you're looking at.
Okay. Cool. So I guess it is good to be able to see, CPU percentage and load and memory and network.
Yeah, so like an example where it was it Ganglia we were using? It might have just been the EMR. So it was basically cluster level metrics rather than getting into the nitty gritty of the Spark job. But we're able to see, the memory and CPU both climb, and then all of a sudden just drop, and like nothing was happening for a long period of time. None of the stages were moving. And so it was at least a little bit informative. But of course, we then, my experience is like go into the logs and hopefully you have those kind of routed in a cleaner way than looking on HDFS like I always did. And try and figure out what last happened that was meaningful and that kind of thing.
Yeah. Okay. Cool. So that was that. That was that. Other Spark UI tabs, storage environment executors. And then it says there's also a REST API and a Spark UI history server. So can I see that of a previous cluster?
Oh, what's the cluster?
Yeah. I've had some other ones. But I don't think you can get to that
No,
using
this is-
Databricks because it's all community online. Yeah.
Well, I don't know that. I don't know if you separate the Spark history server from the Spark cluster typically.
What do you mean?
Probably should. So for like bare metal, long running Spark clusters, well, I shouldn't say bare metal, for virtual machine Spark clusters rather than to spin them up and down and destroy them so frequently. I think we had Spark history running within that cluster somewhere, right? Like on a master node or something within that cluster.
But it looks like these are only useful outside of clusters, right? The history servers. I mean,
It's useful out, I think what they're saying is it's useful outside of the Spark application. So once your job is run and worked or died, like the Spark history server will keep information about it much longer than the normal Spark UI.
I see.
No, I don't
I see.
know. I'm kind
So
of
is it-
curious to learn more about what's going on with the UI that we see through Databricks and if they're kind of merging together those concepts or if it really is the traditional UI.
So if you're saying that the history server is for, you're saying it's kind of like results?
I mean, that is, so this is the, click on your Spark UI tab again.
Mm-hmm.
This is the history server, I think. No, you just didn't say it.
No.
Okay. When I click on the Spark UI tab in Azure Databricks, the host name is history server. And so,
Mm.
because like,
Oh, are you looking at a previously dead? Are you looking at a cluster that's no longer alive?
it is a cluster that is not running, that's true.
Okay.
Maybe they swap over when it's.
Yeah, they switch to history
Yeah.
server when it's all finished, and mine's still running. So mine, yeah, that's pretty cool.
Does that automatically.
Yeah,
kinda
that's pretty neat.
convenient.
Let's
Mm-hmm.
see what changes.
Yeah, it's pretty cool.
That's good that Databricks is doing something about it because that never. I'm sure building it made sense, but like using it, you're like, why do I have to go to a different server for history? Why isn't it just all kind of together?
Yeah, that makes sense. All right, so the next section is on debugging and Spark first aid. And so, using it in Databricks, I feel like this is sort of abstracted from me. Maybe not Spark jobs don't start. I mean, that I guess could be, I just have some sort of error. But the Spark UI does not show any nodes in the cluster other than the driver, or the Spark UI seems to be reporting incorrect information. Right. That's like abstracted from me, I feel like, in this
Less and
environment.
less important
Yeah.
to everyone.
Hey, can I ask a really dumb question?
I
So
think there is a.
the command line stuff that they talk about in the book, is there any way for me to play with those when I'm also using the community edition?
Yeah. I mean, yeah. So the way that it tells you to get started using those command lines, I don't even remember what that was actually in here, but I thought it was like you're running a what?
But like
Like a
you said, Spark submit or something like that, right? Like,
Mm-hmm. Oh, you
can't
mean
do that.
you want to run Spark submit while in Databricks? Is that what you're saying?
that's what I'm saying. Like, I don't have a Spark cluster. I'm just so far I didn't install anything. I'm just using Databricks community, like, and everything works
Yeah,
great
use
from
Databricks community,
I
Databricks
use the notebooks, right? And
Mm-hmm.
that works fine for the RDDs, for the structured APIs, for
So the one that they're talking about in the book, so there is a Databricks CLI if you want to do command line stuff and kind of work within the bounds of the community edition. So you can access the HTTP.
I don't know, I feel like there was something about that in the
I don't know about community edition. There are ways, apparently there's ways to SSH into your Databricks cluster.
Oh,
But I doubt that it's going to work on community edition. That doesn't sound like something they would want to set up.
Yeah, that's a good point. Yeah, because you're going to be sharing. Yeah, physical hardware. You start in this interactive mode.
maybe there's
When you
somewhere.
I don't know where it is. I thought I remembered.
You can run some commands from the notebook. Spark submit, I don't think would be one of them. That would that would work. But you can run like ls commands and stuff from the notebook. Which I just saw today.
Yeah. How would you?
Let me see if I have the same one. It's in the right workspace. But no, there's something like percent ls or something that you can do like as a command. But Spark Submit's different. You don't really need to do Spark Submit, I think.
Right, because when you're doing run cell in a notebook,
essentially,
that
that's
is
what's
basically
happening
doing
behind
it.
the scenes,
Yeah,
yes.
the Spark Submit.
But I mean, I don't even remember, but just the various other command line, things that are in the book. It's like, oh, well, I'm just skipping over this. Can't actually try.
Yeah, I think on it, like if I was going to try those, I would either get a Docker container or just install Spark on your machine, which is somewhat easier said than done.
Perfectly logical.
Yeah.
Yeah.
If it's your cloud environment that it's in, I think there's ways to do it. But that's going to be harder than the alternative, or at least more expensive than the alternative.
Yeah. I mean, ultimately, I think if I care enough, then I will just.
No, it is just I tried to do it and I messed up Java completely because it turned out that Oracle recently changed how it's installed on Ubuntu and well, I messed up instructions.
Yeah, that's the drawback of running it locally is you'll have to go through the I guess once you have Java installed on your machine and working correctly, the install looks like it is just a tar gzip. So you could just extract it and run it.
Yes, but there are environment variables that it's going to look for, and it may or may not get those right automatically, is my experience.
Gotcha.
On Windows, there is a WinUtils file. I learned this recently. There's this WinUtils file that is needed to do like Hadoop file system commands that doesn't come with Spark, and so you have to go get that. It's actually not that hard to do. But,
a lot of extra steps, and you have to spend time searching for those. All right.
I do have a good link that was pretty helpful, but you end up learning a little bit more than you want to use it.
I see. Well, paste it into the chat, maybe. Okay. Let's see. So, yeah, I don't know how much I have to add on here. Do you have anything? So there's like Spark job's not starting, errors before execution. I assume the majority of your errors are going to be errors during execution.
Depends on if you can overcome the ones before execution.
Right. That's a good point.
Eventually,
Once
yes.
you get one to run successfully, hopefully, you can just clone your settings, right?
We would have a lot of submitting a job to a cluster and trying to tell it which dependency files it needs in order to work. Like we'd be pointing to config files in S3 and things like that. And so we'd have a lot where the Spark job started, but not really. The Spark context never got created because as it's trying to pull everything together, it doesn't find a file or a config's missing. And like that was in Java, so it was doing a little bit more upfront, I think, than Python would. In Python, you're probably going to hit more runtime.
You've had an adventure. What time did you leave Temecula? 3 hours and 15 minutes later, you arrive.
Ouch.
Well, he had a flat tire, so.
Oh,
We're talking about productionizing jobs.
Yeah, we're talking about some of these error troubleshooting things. And I was asking what's the most, what are like the most common errors that you run into? And Dustin was saying configuration related errors are in his experience a lot of the errors that you run into.
It talks a little bit about out of memory and garbage collection. I think those are pretty. You can hit those quite a bit.
Right. So if your
But I
cluster,
wouldn't dig into them until you hit them. It's tough to get your head around.
So if your cluster doesn't have enough nodes and you're trying to do too much work on a small cluster, that's when you hit those sort of things. Excuse me.
Or if it's not utilizing enough of the memory on the cluster. So like you can.
Oh, I see. If you've allocated.
It has default number of executors and things it's going to try and do, and then you can tell it what you think it should do. And yeah, so if it's trying to do too much in a single executor, it'll run out of memory even if the cluster has a lot more.
Did we give up on streaming?
No, we got it. Finally.
No, I mean, streaming the.
Oh, no, I'm just using my default mic. I mean,
No, but you are streaming. On
I am streaming. But I'm hesitant to switch mics at this point. So it was so difficult getting it running. I had the same experience that you had a couple times ago where, yeah, well, we're now going to be forced to have a new system because support for this stops in 2 days.
So Twitch.
Something. What we need is a way of screen sharing and,
Twitch.
okay. All right. I look forward to instructions.
So we're not here at streaming. Okay, I'll figure it out. We're not streaming yet in the book.
No, we're not streaming yet in the book. Yeah. So that was like sort of the end of the errors. No space left on disk errors. I mean, those I assume are pretty easy to troubleshoot, although.
Well, they're not as necessary when you're using mounting block storage.
Yeah. It'd be, in that case, it'd be like no cost left in budget.
So I will say if you're using like EMR or something where you actually do have to do some amount of choosing the resources and you're starting small, and so you make everything small like you want to do in the cloud, those disks aren't going to just like scale themselves for you. And so sadly, I have seen no space on disk in recent years, but it was not that hard to correct. It was just a lot of staging stuff happening on the local storage versus the final destination being cloud storage.
All right.
so
Yeah, go ahead.
the work that you've done, your storage, is it running on the same nodes that are your Spark nodes, or is it running on a completely different architecture?
Almost everything I've done in production or pseudo production is it's actually like a cluster with Yarn. So it's a Hadoop cluster with Spark on it, basically.
Yeah, okay.
Even if all we were doing was Spark, it had HDFS and that was local to the Spark.
Because I know it's getting into the streaming, but then when they talk about cache things, I was wondering, I assume that if it's an external storage, you don't want to incur the cost to write it to disk external. You want it to be local to your node, right?
Well, wait, if it's a result, if it's an output, you'd want to get it off your node, right?
No, we're talking about caching. So when they say like, oh, you got this data set, you're going to run, 100 different, machine learning models against the same data set, same starting point. So let's cache it now, and then, it'll just the next 99 times I need it,
It'll be there.
But obviously, you'd want that to be local. You wouldn't.
So you want it to be in memory, right?
In memory
I know that.
at first, but it says
So if it doesn't fit in memory,
if it automatically doesn't have enough memory, it says it'll go to disk. But I didn't really stop it. I was just wondering.
I'm still the mindset that you do if you can, but you probably don't want to manage nodes in a cluster just to have that benefit of caching with disk. Like you can gets more complex to use things like Redis or something that's more of like a external system for the caching. But yeah. Thanks.
All right, and that's you know, I guess the end of the monitoring. Performance tuning.
Well,
Yeah.
On the caching, Ed, are you just talking about the dot persist, or was there a different syntax for caching?
You know, I don't remember, to be honest. I can look
I think it
for
was
it.
just dot persist, because without dot persist, the action makes the whole data frame read memory.
But I saw some comment that said if it doesn't have enough memory, Spark will go to disk for you behind the scenes without you having to explicitly manage.
So in relational databases, we call that spooling. With it spooling there.
It's the same concept, yeah. And then when you're running like Databricks Community or Databricks Cloud, I don't know where that's going to go to by default, but they've certainly considered it. So
Let's see if I can
I mean,
find
there's
that.
clearly virtual machines running.
Yeah.
underneath-
That's what I
underneath
was-
your clusters. So I would guess there's local
Still
stores
same
that they're
thing.
managing.
Yeah.
But
I would
which
guess
makes you
that as
wonder
well.
if you can get an out of disk error. Right?
You should be able to, I would think. If you've got because it's just going to be, this is running in AWS, so it's just going to be using a EBS store or whatever,
And that's going to
Um,
be fixed.
and that's going to be a fixed
Less
size.
whatever's already there
Right.
for the OS and
And
Java.
so I would assume if you're running, and the cluster sizes here are very small.
Why would it be an EBS store?
I'm saying like the backing store for this virtual machine, a node of the cluster would be an EBS, right? That's how AWS works. Like it's all,
either the ephemeral disk or the
and it'd be
Right.
EBS. Yeah. So
Ephemeral disk or EBS.
yeah, like in other words, the machine is actually running and there is a small amount of physical hard drive, on the thing, but then there's also a elastic back storage, and that's if you're creating.
Elastic back storage, is that what EBS is?
Yeah, I think so, something
I
like
thought
that.
it was elastic beanstalk.
No. Beanstalk is just called Beanstalk. EBS is what the storage is called.
And that is not S3, it's a
Elastic
different
block
storage
storage.
system that they,
Yeah.
sorry about that.
Yeah.
Yeah, because it's not distributed.
Yeah.
Correct.
Yeah. It's like, well, you can like unmount it and mount it elsewhere. You can take an
Yeah.
EBS that's mounted on one EC2 instance
Yeah.
and you can unmount it. It's exactly like managed disks in Azure.
I
You're
was gonna
probably,
ask, it sounds like managed.
Yes.
yeah, that's
But
what it
managed
is.
this is still backed by Azure Blob Storage.
It's possible that they use S3 underneath the covers for that stuff, but I don't think so. So if you remember when Azure came out, they had the notion of block blobs and page blobs and whatever, and so it made sense that they were putting their virtual hard drive storage on page blobs, right? VHD stuff was going into page blobs. But S3 didn't have a concept of page blobs. So I'm guessing S3 is really just block blobs, right? Exactly. And then they had EBS, which is page blobs. Yeah. And it was also weird how, like, if I remember correctly, and granted, this is a long time ago, right? Because we're talking about EC2 first launched in like, I want to say they went public in like 2007 or 8, end of 7 or early 8. So this is a long time ago. But my recollection is we didn't get EBS until like a year and a half or maybe even 2 years later after EC2 launched, right? You would write everything locally, and if you wanted to do some thing where you backed up, you always just pushed it to S3, right? It wasn't later that they gave you that ability.
Okay, never mind. Now I understand.
Okay.
So by the way, it's in chapter 19 and it's an explicit dot cache.
On the data frame itself,
Yes. So you say data frame dot cache.
and that ends it in memory for a while.
Where, oh yeah,
In-
temporary storage cache.
yeah,
In
so-
memory, unless it's too big for memory, and then it uses whatever the local disk, whatever the closest disk is.
Yeah. Caching will place a data frame table or RDD into temporary storage, parenthetically either memory or disk, across the executors in your cluster and make subsequent reads faster.
It's in the data locality section.
That's in streaming chapter 9. Wait.
No,
oh no, this
no,
is performance tuning. Sorry.
performance tuning.
I'm
Yeah,
in the
page
chapter-
326. Chapter 19.
They're like
At table 19 dash.
temporary data storage.
Yeah, if you look for table 19-1.
It's fairly close to the end of chapter 19. So it's only
Yep.
like a tiny bit.
Yep.
Windows does a good job of not letting me know if I'm near the beginning.
Well, I was saying if you go to chapter
You, like,
20,
click an arrow,
no,
you'll
I'm
go,
saying
there's,
you
like,
just go to
20 more
chapter
pages.
20 and then just go back a tiny bit.
You're smart.
Oh, sorry,
So-
I know I jumped in.
Yeah, no, it's okay. So we were talking about caching, and it does say there's a bunch of different modes for caching. But I don't see them specify in the cache. They just call it cache boom boom. Sorry, open paren, close paren. And then what's the default?
Oh, actually, if you look at the table 19-1,
Yeah, that's what I'm talking about.
Yeah, you can configure like memory only or disk only. And so it's pretty
Oh, it's
clear
an
to me
option.
when they talk about it, they're talking about the disk that the JVM has access to. So I think it's exactly like you were saying.
So
It's
in
whatever,
on an EC2,
whatever the JVM itself is stored on. You know.
well, in the EC2 instance, it would be probably on the EBS. It would be on the elastic,
Yeah.
the backing store, basically block store. Yeah. Okay, so going previous to that, they say, which I totally agree with, one of the biggest performance, consideration is how it's actually designed. And yes, and here it was interesting because here they're recommending Spark R for certain types of systems, and of course Spark Scala or Java for typed, if you need typed data sets or whatever they're called. And also if you want user-defined functions, they say typed data sets, are a good thing. I mean, like Scala, they would recommend Scala or something like that.
Right.
You mean just what would be typed?
Yeah, type data sets, remember, enforce data integrity in and out of the data frame. Am I saying that right?
So instead of having a data frame of rows or data set of rows where Spark knows, like Spark kind of knows the schema that goes with the row, but it's kind of this generic object. You actually would give it like your person object. Each row is going to be a person object, and if you're breaking the rules of your class, then it won't compile.
So-
Right.
Well, this
Yeah,
was
we
the
talked about
whole
that.
Data
Data
sets.
frame, data set, RDD are your
Yeah.
three
Yeah.
choices. Right?
Data sets aren't flat. They're more like collections.
Well, collections.
like strongly typed collection.
I
Like a
wouldn't,
data frame. is
like, I wouldn't call
rows
them-
and columns, right?
Yeah, but they're flat still. But yeah.
A data set is.
I wouldn't call it flat. Like, it does have rows. It
Yeah.
for sure has rows, so it is very structured
And
in that way.
And it has columns. It's just the columns are untyped collections, which is what you were saying, right? It's like what is it? Kind of like well, in .NET it would be like you have a list of object versus a list of person. Right? And so in a list of object, you can have a row structure with 5 columns in every single one of those elements of the list, but you just don't know what that is unless you cast it in and out, right? Whereas if you have a list of person, there's no way to get a person into the list without it being a person. The actual insert would fail, right? And so every getting it in and putting it out operation does the type checking for you. And they recommend Cryo. Am I saying that right? Or is it Creo?
For serialization.
Can you tell
Yeah.
us what it is? Oh, I say cryo. I don't know. No, isn't it KYR?
It's KRY. Cryo.
Yeah.
Cryo.
That's what I say,
I think-
but I've never said it to an expert and found out if I'm right, because I don't.
Yeah.
Well, I think of it as cryo, like you cryo.
Cryogenic.
produce a
Yeah,
person,
yeah,
you're-
exactly.
You're
Yeah.
serializing and persisting your.
Yeah,
data.
I agree. That makes
Probably
sense.
what the person that made up that name was thinking.
Yeah, I agree.
I mean, who knows? I've never used it. Acronym.
So they talk about scheduling. I'm really the wrong person to lead this part. Come on, get up here, Ike. Help me out. Table partitioning, bucketing, data locality. That's what we were talking about before a little bit with the.
I mean, obviously, anything having to do with partitioning, bucketing, and avoiding shuffles
Is good.
Is could save you massive
Mhm.
performance, right?
Well, like you did a Spark spike where we grabbed and ingested 5 gigs in a splittable compressed file, and it was done in like 90 seconds. It was just everything mapped and aggregated and emitted, complete operation time, like less than 2 minutes. So there's no like other ETL tool that operates that quickly, without a lot of work, right?
And then
But
if you
if you wanted to parallelize an ETL tool to do that, you're putting in a lot of configuration effort into parallelization.
Yeah.
But in this,
It figures it
we
out.
just said, run it. Yeah. And it's like, oh, this is a splittable file. Oh, it's about this size. Oh, I probably need 4 nodes.
Yeah.
But if you then repartitioned, it could have taken potentially longer than it
That's the
took.
part that I'm a little fuzzy on, and I'm fuzzy on it with Dustin right now. Dustin and I are writing a Spark project that's due in like 3 weeks. And, when we have a bunch of files that we're ingesting, right? We have 7,000 files up to 2,000 files a day that we're ingesting. And those files can be as small as like 100 megs, and they can be as large as what's looking like 1.5 gigs or so. So do we leave a cluster running and say, no matter what, we're going to have 8 nodes run? Or do we say, no, for the smaller files, we expect, you know, two nodes or 4 nodes, and for the larger files, we expect 8 or 12. And do we let, like in the Databricks world, this is not a Spark thing. In the Databricks world, Databricks will make that decision for you. It will submit to the driver. It will create a DAG. It will specify your degree of parallelism, and it will spin up the cluster for you, right? So it does that as part of its compilation. You know, in Spark, it's not as dynamic, right? In on-premise Spark, you create your Spark cluster and it stays relatively static and running. But in Databricks, it does not do that. So what I don't know is like, what's the knob we turn here? Like, do we just let Databricks make its own decision on parallelization? Or do we hint at some kind of method of controlling that? I feel like in our POC, that's like one of the major things we should be resolving.
And once you get it ingested, is there heavy processing or no?
No, for what you mean for our particular use case?
But yeah, for this.
All we're doing, the answer to that is maybe. So what we know we're doing is what's called translation, which is the files can come in various formats, and we are anchoring those formats to a golden master. So we're saying this column is that, this column is that, this column is that. And so maybe in part of that, we may split a column or merge one, but I think that's it. But that doesn't sound bad. No, that doesn't sound bad. In the next version, it's way more complicated. We are multicasting potentially. We are definitely dealing with hierarchy data where we're diving into the hierarchy and grabbing the elements we care about. We're doing external lookups to either a Redis cacher or we're not doing external. Actually, we killed that. We are ingesting internal.
It's external to Spark.
Maybe not.
Yeah.
Maybe not. So we're basically like, if you can do the batch transformation in Spark, we're probably doing that type of transformation somewhere. We're doing checksums, like it's a lot. And we're doing it in some type of weird rules engine where we're saying for this pipeline, for this customer, for this data type, these are the rules we want you to follow when we run through the pipeline.
Yeah, I mean, it does sound like there's the possibility that you could get away with your nodes for small files since you're not. Right? If you were doing some monstrous calculation once you got it, then you might have all the nodes. It's not like you have small files.
Yeah. The challenge is that the mission statement for the whole project is that all files will be completed in a reasonable amount of time. And right now, some of their files take 24 hours to finish processing. So we have the expectation that those files will take 20 minutes to process.
I was curious what number you're going to say for what's reasonable.
We don't have that number yet.
We don't have the
I
number
made
yet.
that number up.
Not 24 hours.
We know 24
So every time
hours
someone
is
says, so it'll only
unreasonable,
take, I'm like, oh, what number are they going to say? This will help us.
right? They never say it. They're always like, better than what we've got. Like,
I mean, even like an hour or two, you know, if you're talking about 24 is like
Right,
catastrophic to the business, you know,
Yeah.
or
But if I'm a company sending you a half gig of data and you're like, it'll take 2 hours to process, I feel like that's right.
depends on
Like,
what it's doing to it. But yeah, I can see that. I mean,
But if I'm not doing that every minute, I don't really care.
Yeah.
If I'm doing it once a month or once a week, I'm like, all right, take as long as you need. Like,
we got to get going if we're going to get this.
yeah.
So statistics, I ran through an exercise on stats, and it was pretty astounding. So because the driver does lazy evaluation, it's making decisions based on what it considers the distribution and the skewness of the data. And it's only doing that on sampling. So it looks, when it decides to evaluate, it just quickly samples. But sampling is a terrible way to figure out skewness, right? Like no matter how you do it, you're not really going to get a full distribution idea of the data, right? So what you can do is you can create statistics beforehand, and it will scan all the data, and it will produce a histogram, and it will save it. You can look at it. It's pretty neat. It functions very similarly to the way Postgres or Oracle function. When we did that, we could see the exact same like group by aggregates run way faster when it knew what the data was going to look like. So it made a lot better decisions as it related to partitioning that data in a group by and aggregation.
Well, you don't know ahead of time for all of eternity how the files are.
Well, they're worm. So for that run, I mean, yeah, I don't think you're creating statistics that are persistent.
But I'm saying you couldn't just manually decide this is how I want you to partition it. No, this will be unskewed, it'll be balanced.
That's a good question. I don't know that. I think you can though.
It's like it's hot.
No, I don't mean program wise. I mean your exact
the reason
customer's
we call it
data.
repartition is that you know the data and you understand what's going on in your application enough to say, hey, let me just tell you a way to partition it to speed up the next steps, right? So if you're doing some sort of sorting or something, grouping, if you're doing grouping, you might tell it to repartition in a way that you know is going to work well.
Right. Like
how you get that level of knowledge across the board is the tougher question. Yeah, with statistics, then this is for, according to the book, it's looking like these are like tables that are persistent, right? That you can do statistics on. Are you creating that, or in your example, did you create the table, run the statistics all as like a one-time thing just because it gave you that much?
Well, yeah, in my example might have been derived.
Yeah.
We were in production, but yeah, it was, we created the table, we built statistics, we watched the cost-based optimizer making better decisions on aggregation and partitioning.
But there's a cost to the statistics computation itself.
Not that I noticed.
Oh, really?
Yeah, but maybe my data set wasn't large enough to let me notice it.
Yeah.
But yes, you would figure if it had to create a histogram, it's definitely going to have a cost. I'm wondering can you load the table, create statistics, cache it, and then run the modeling over and over again that you want to do? I'm wondering if that's the
Just tell it to assume the statistics are still the same as the last time that you did that.
Well, if it's in your input data, there's a good chance it is.
It's actually I'm talking out of school here, so I don't have my computer open, but I believe the stats were saved with the table, and you could examine them with the table.
But you're talking about changing the contents of the table, but telling it, trust me, the stats are still the same. Is that what you're saying?
Well, no, that's an interesting case, and I didn't do that. I didn't say, hey, let's play around to see what happens when the stats get outdated. My guess is it doesn't detect that. So my guess is you would have to know that the underlying data changed, and you'd have to go regenerate the stats.
Mm-hmm.
But like in regular stats with histograms, it takes a lot to change the skewness of a large data set. So like if you have, like in SQL Server, if you have 1 billion rows, you won't even trigger SQL trying to regenerate the stats until you have basically 100 more million rows in that data set, right? More than that, more than 100 million more. And then it will say, oh, maybe the data changed. But if you have a billion rows and you add a few million, you add 20 million, it assumes you didn't do enough to change the skewness of the data.
It's almost like you need a stream processing system to compute the stats so you can do your batch processing on the, like,
Well,
Well, that's
real
what
time.
s-
Yeah.
That's what SQL does, except you wouldn't want to be recalculating the stats all the time because you would just like to Ted's earlier point, you would consume all the performance gains that you would get by even having stats, right? Like there's a breaking point where you're not actually gaining any benefit. You're constantly recomputing your stats. You don't want your stats recalculating all the time. The overhead's too high, and it's too high on the CPU.
I'm saying like if you have, I see what you're saying, but if you had a streaming system set up that was just as the files were coming in, writing stats.
Not saying if you had a billion rows in your table, even if you inserted another 2 billion rows, so you now have 3 billion. If you were watching them,
If as they're coming in, you're just like update. I'm saying I'm trying to
telling you I know how
segue,
stats work, and that's not effective.
trying to segue over here
Right,
into
okay.
streaming. And
You can segue, but that particular example is a problem because the histogram is only going to be 200 steps, right? It's not going to be an accurate representation of the true skewness of the data, right? They're going to bucket it into 200 buckets. And
right.
you're talking SQL Server.
Well,
Because SQL Server has a very different goal for the statistics than Spark.
does it? No, it doesn't. I think it's got the same goal.
I thought that
No, I think they're both trying to do the exact same thing.
SQL Server was more interested in uniqueness.
Nope. SQL
Which-
Server's interested in index usage and whether to seek or scan. So in a way, yeah, uniqueness, like they're concerned about seeking or scanning.
Right, seeking or scanning and also hash match performance.
But
Right.
that's a similar thing to what Spark is doing, right? Particularly,
But Spark's looking to partition and distribute, which I guess at the end of the day,
Well,
no, because it's not
They're
just
trying
about,
they're trying to optimize the reads, aren't they?
they're
Isn't that what
they're
their
doing,
stats are doing?
Spark's doing two things, as I understand it, right? One thing is it's trying to avoid shuffling, right? So it's trying to pick the optimal partition so that it doesn't have to shuffle, right? The second thing it's doing is it's pushing down as much of the analytics as it can. So it is trying to use the source systems API and to tell it what to do so that the source systems API avoids scanning the whole data set.
those things are true, and I might be overly focusing on one use case, but there is a particular use case where you say, oh, look, I've got 1,000 rows in my customer table. Why don't I just partition this in by customer ID? Except that 999 of your customers are mom and pops, and one of your customers is Walmart. And so now 90% of your data is in Walmart, and you've got one of your nodes that's completely bogged down and all the others are right. That's what you don't want to have happen. That good statistics will tell you don't do that.
Right, but there's
Right.
a lot of other things that statistics are doing, right? Like if you're trying to find your max sales date for partition, right? If you can push that down, like if you know by the skewness of your files that the file is partitioned by customer ID, and you know it's ordered by order date, right? You now understand something about your data that means you don't have to scan it.
Well, it's partitioned by that, but you don't even need statistics.
Yeah, I think if you were trying to do a max on order date, you would want to know how the data was organized. Wouldn't you?
Well, we can take it offline if this is taking too much time. But if you truly partitioned it by date, and you had different files for each whatever month, week, day, whatever, then you would just go straight to the last file. You wouldn't even bother, and you don't need any statistics to know. I'm just going to go to my last file.
That's true.
If you had really good statistics, but you partitioned it by customer, it doesn't do you any good. You still have to touch every customer to see where the match. You might know it's easy, you might know it's hard, but you still have to touch every customer. You have to split it out if you can.
But your stats help you understand how many customers you have.
Your
right?
customer
And so
stats tell you that, but I'm saying your date stats don't think. They might help you estimate time, but they won't help you actually get it done.
We wanted to do an experiment where we profile the driver on SQL Server. We wanted to connect SQL Server as a mount point, as a source, right? And then we wanted to see how intelligent the DAG really is in pulling data out of the table. But we didn't do that. But it would be an interesting idea if we did it.
Okay, so going on to streaming, which is pretty interesting stuff, I think. So it says that there was just like in the RDDs and the data frames and the data sets, it was, there's a dstreams API, and then later, like 4 years later, it looks like they came out with a structured streaming API. And these days, you're probably going to use the structured streaming API. It talks about some use cases. And I was talking about update data to serve in real time as the use case for those statistics. If, you have kind of like a shared community edition of Databricks that's populating the statistics to use for a real frickin' production version, you need the statistics to be right, and because it's handling a lot of the load. That's what I was talking about. But there's a bunch of others, real-time decision-making, online machine learning, which they say is the most complicated.
Which we're doing next month, right?
Yes, that is supposedly next month. And they talk about some advantages and some challenges. And, the big challenge being the data might not arrive in order because it's a distributed system. And they talk about that thing called event time, which my only exposure to this had been, what was it called? In Azure, it's called Stream Analytics. Stream Insight. Yeah. And it has it's just like SQL, just like Spark is, but it has a special by timestamp clause where you indicate which of these columns is the event time. Yeah. And then they talk about continuous versus micro batch. And they basically say that right now, I don't know if it's still true, I didn't look it up, but Spark is micro batched because, I underlined that, hold on. Oh, streaming applications that are large scale enough to need to distribute their computation tend to prioritize throughput over latency. So because of that, they chose the micro batches. Okay, and that was about it for the overview. Questions? That there was
they
that.
do have continuous streaming now, where it's basically like
Cool.
milliseconds on the input side. As soon as it finishes input, it goes and gets more, and so you get down to like millisecond timing. That's pretty new though. I think 2.3 is when that came out. I don't know if it's considered preview or GA or what, but that's something that's kind of come out more recently, and for me so far, it's been when we go, yeah, but Spark's going to be micro batches versus Flink doing more just true streaming. I'm like, but maybe that's not true anymore. But we haven't really gone back and changed because it hasn't been critical in the situations I've been.
Yeah, I mean, it sounded like only if you've got latency issues do you even need to worry about it.
But if you're doing streaming, someone cares about latency.
Yeah, that's true.
And
But
it's
at what degree,
what's
though?
reasonable? How quick?
Yeah, exactly. At what
24
degree?
And what I find is that you kind of have like, if you say real time, you're talking like analytics. You're like, yeah, I can get it to you real time. It'll be within a minute. They're like, oh, that's amazing. You're talking to, in a microservices environment, and you're trying to provide the answer behind an API. They're like, real
A
time.
minute.
So like,
What, like 100 milliseconds?
100 milliseconds?
Yeah.
Like,
No, not that quickly.
maybe, but I don't want to commit to that. Like,
Yeah.
that's probably best case. Or
Yeah.
maybe it's not. I'm not sure if that's even, but
Yeah, I agree. Real time means different things to different people. And certainly you could get into some situations where micro batching would not meet your use case. All right, and then they start talking about the structured streaming basics. I thought this was actually a fairly well explained chapter. Like they did a good job, I thought. It talks about the sources and sinks, and then the output mode, although I felt like that one was not quite as well defined here, although it was defined well somewhere else. I underlined some stuff about that. So triggered when that data is output.
It almost seemed too easy.
I know.
I was always like, is it really this easy? This has got to be the easiest streaming solution I've ever seen.
Yeah,
So-
I felt the same way actually.
But then you get to chapter 23, and it's a structured stream and production, and that's where I think it's more
See that I didn't read that chapter.
like
That's
the APIs. The API is pretty clean, I think. I feel like
It looks
it's
just like batch to me. Like
Yeah.
nothing except for the syncing and the destination, where you just are like, when you see data, run this thing, right?
they do a good job, I think, of having it be very similar. Like we were basically setting up stuff where a lot of the middle pieces, the transformations in the middle of the job, would run regardless of whether it's streaming or batch. And then like the actual kicking off of the job is what has to pick the correct source, whether it's a streaming job or a batch job.
That's what you guys are doing.
Yeah, I was a part of that with a much bigger group. Yeah. But yeah, you can kind of not every piece of, if you break out your pipeline, basically your application into a lot of components, and some of those components don't actually have to know if they're in batch or streaming. Because Spark converts, that SQL API into the correct thing.
It almost feels
You know what
like,
I'm saying?
other than the first step and the last step, all of it can be done like that.
Yeah. The
Except for the
exceptions.
sync and
The
Source
exceptions,
and
the
sync.
exceptions
And
are
the-
part of where it gets interesting, but I think those are usually at the source and the sync.
Yeah.
But the source and the sync are super important. So it's not.
Yeah.
That's the thing. They'll be like, oh yeah, it's the same thing if you're using batch versus streaming. And it's really close now, but that part that is different is important. And getting the same functionality you need from the sources using for streaming without building your own source every time is the other piece that it's caught up a lot though in structured streaming.
Did I understand this right? That fundamentally, if you are running streaming, let's say every 10 seconds, little micro batches, and you say that this mobile, IoT data, whatever, could be delayed 30 minutes. Fundamentally, I have this 30-minute, high watermark, whatever they call the thing, right?
Yeah.
That I could need to reprocess essentially the last 30 minutes worth of micro batches.
No.
This out of order event finally comes super.
Wait.
duper
No,
late.
I understood that differently. I don't know if I'm misunderstanding it. It's totally possible. But I saw it as if you have, would you say 10 seconds as your
Yeah.
micro batch? Okay,
Mhm.
so 10 seconds and 30 minutes
Is your watermark.
watermark. You're going to get one answer in 30 minutes and 10 seconds for the first batch, and then an answer every 10 seconds after that for the subsequent batches.
That's an easy way to implement it, but then your latency sucks.
Yeah, but that's if your watermark specifies that you can get an event that late, then otherwise you're giving them wrong answers.
And then overwriting them. That's what I meant by I was
But
trying to
I don't
understand,
think-
are we reprocessing? Are we wait? Right. Fundamentally, you're either waiting 30 minutes or you're reprocessing.
As I understand it, there's state. And
Yes. Either way, there's state.
Yes. And
So
so
the
you're not reprocessing.
Reprocessing, it sounds more dramatic than the way I think of it. So
Because the query.
I don't know if you're right or wrong, but to me, that's not
so-
the way I think of it, because I'm not going back to the source and
Yeah,
starting fresh.
let's say it's a group by, this thing comes in late or whatever, it just gets put in an earlier group rather than a later group or whatever, right? It's just another event that's handled, right? Or if it's like a max, is it the max? No. Okay, well then throw it away anyway, right? Or, I see it as just another event that's coming. It's just how the watermark is how long you have to hold the state in order to give the correct answer.
Except where, and this is the part that confused me, when they switched from grouping it, aggregation fine, that's an easy use case. Right?
Yeah,
You
yeah.
can do that, right?
Yeah.
It's when they're like looking for a pattern recognition. Like,
Mm-hmm.
we're looking for events 10-1-3.
Right.
If you see 10-1-3 in that order, we're fucked, right? So, 10-3, and there's a 1 coming late that it went in the middle of it, right? So we recorded the 10, we recorded the 3, 20 minutes later, the 1 slipped in. Then now we have the event condition for alerting that we were worried about.
Right. And in this
You have to
situation,
wait half an hour to get any alert.
absolutely. That's correct.
So I have
It would have to
seen
be.
Spark work that
Yeah.
way. I don't think that's the only way it works though.
It would have to be. It would have to be.
But like you have your output, so you have your 3 output modes, right? You have complete, an update, and append.
Yes.
And so if you do complete, it's going to keep this table, this streamed table of your window. It's going to like keep that and then output the whole dang thing every time it happens. And so I don't think it waits, and we could test this, but I don't think it waits to give you the first shot of it in that type of mode. But it's going to keep pumping it out and it may or may not change.
Okay. I agree in. Hold on 1 second. So these output modes, how does that relate to the notification though? Because in notification, it's is there an event or is there not? It's not like because think about it.
Is
In
there,
the case
is there
of
a use case in here that you're thinking of, or are you just
I-
well,
talking?
in the
I-
case of a 10.1.2, yeah, that was one of the use cases. Where hook me up with the page number there.
371-ish?
371.
No.
There's a reason why some of us buy paper books, even though I like to read on a Kindle.
It's like, and I love Netflix, but it's like the Netflix show where you don't know if you're close to the end or close to the beginning.
But sometimes it's a good
Is this
thing.
ever gonna like? Well, did I already see this one? I really don't know what's going on.
No, but if you don't know, is this the climax or is this just a red herring? I like it when I don't know. Otherwise you're like, oh, there's
So
only
I have
5
a
minutes
really
left in the movie. That's
I
guy's
have a
done.
really stupid question I really don't understand. So in batch mode, it's easy to understand that the RDD is immutable, right? Because the data doesn't change underneath the RDD, right? But in this case, the RDD is getting added, it's additive. It's actually additive or
It's-
updated.
It's partitioned by whatever you call it, arrival time, not event.
So you're
No,
saying
it
that-
can be partitioned by event time as well.
Well, okay. Perhaps technically it can, but I'm saying conceptually, every micro batch has to be operating on different RDDs because they're immutable. And
Is that
so,
true?
Well, but no. Hold on.
That's what I didn't understand. And they
Yeah,
didn't really
I see it
explain.
as like string builder. Sorry. So it's like it's going into buffer and then it's becoming an RDD. Right? Like it's got a buffer, an in-memory store, and then as the time window elapses, the watermark passes, the blah, 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 whatever, some event, then it's like
yes,
this
but
is
what
an
I'm
RDD.
saying is once that micro batch commences and the next micro batch comes along, they have to be separate RDDs. You can't be buffering across micro batches.
No, I think you can.
You can always copy the RDD into
No.
a new one that has appended data, but you can't actually just append to that RDD.
No, it hasn't become an RDD yet until your
No, it's
watermark
batch
expired.
already. Oh, well, okay. Well, then that's a whole. Yeah, we have to answer that other question.
Right. That's what I'm saying. So if you've got
So if the watermark passes,
yes, then that thing is an RDD and it's immutable. Damn it. Yeah, I agree.
right, we
yes.
have to agree.
Or if there's
completely agree on
no watermark, right? Then I also agree. As they're coming in, boom, that's an RDD. RDD.
that.
Right?
Nothing else you can do,
So
right?
these
Yeah.
are you're telling me that as the events come in, we're getting one record.
Yes.
Well, if it comes in slow enough, obviously it comes in really fast.
Yeah. You have a table with one row. Yeah, absolutely. That doesn't sound that bad if I say it. There's a table with one row, right? Of course there's a table with one row.
It just sounds ridiculous to have a million tables with the exact same schema.
Well,
But
I
if
mean,
they're partitions, it doesn't sound as silly. It's still inefficient.
and remember that, some of the schema and stuff can be stored separately, right? So you can have a table, 20 tables, all with the same schema, and the schema can be stored centrally, and these are just, you know what I mean?
Is this really how this works? Is that
It's how it has to work.
So here's the way to think about it. I don't know about how, but Debugging Das, who was the lead developer on Spark Streaming, explains that a structured streaming as a table that is constantly appended with each micro batch. So if you think of it as there's this state of a table, which is a certain period in time that's allowed to impact it, and each micro batch that comes in is going to be processed and then applied to
So
that
that
table.
sounds like one data structure.
So whether that table is immutable
Big
and they're throwing it
partition.
out the I don't know. That's an interesting question that I almost want to research and I almost want to just move on with my life because I don't know how it changes the way I program here.
Well, you're going to be speaking at a conference about it, so I almost guarantee you're going to get a question like that.
But you can answer it the same way.
But I mean,
Who cares?
You
can answer it with who cares, even if you're in front of an audience.
Yeah. So the other thing that I got from this guy's talk that's awesome is he describes it as fast, fault tolerant, exactly once, stateful stream processing without having to reason about streaming. And I love that description, even though it's a mouthful. But then we're here talking about, but what happens at the deepest levels of the state of the structured streaming, which is cool.
Well, I just don't understand. If I'm streaming and the events are coming in, where is my huge benefit in parallelization? Like,
So
where's my big lift here? Like,
Okay.
why would I need an 8-node cluster to be reading shit off of one string?
So a single cluster can support, let's say, 1,000 events a minute. I don't know. I'm trying to make the numbers easy, right?
So you think 8,000 events a minute, or you think Spark is looking at the data frame, it knows the partition. It's saying, oh, I'm reading shit off the stream for every Disney theme park or something, and I know which node that event goes to get added to the RDB, so I can query it faster.
Yeah. Right. So like there's a certain velocity that a single node can support, and you're scaling that out.
And if you think about like the way people talk about Kafka and the throughput capability there, a lot of times it's coming in tandem with Kafka or one of the Kafka competitors. And
yeah, but I use Kafka a little bit, and this seems a lot easier than Kafka. Like,
agreed.
Yeah.
I'm not even sure. I mean, they talk a lot about using Kafka as a source for the stream, but a lot of what Kafka does would be like log analytics, where they're dropping log files in, and Kafka is reading it and publishing it. Like, it's, if I had to write that solution in Kafka or Spark, I'd write it in Spark. I'm not sure I'd write it in Kafka.
I have a question, actually. Databricks. So these are the sources for Spark. It's mentioning in the book here the Kafka, files on a distributed file system, or a socket. So does Databricks?
Socket implies pushing.
No, socket's a two-way street.
Oh.
Yeah, either way.
But no, I mean, it implies that it could be pushed.
Yes.
That I can fire something off directly into the stream.
Absolutely, it does imply that. Yes.
That's cool.
Yeah, and so that's where I was going with this. So does Databricks, does Azure Databricks, I'm sorry, does it add to the event source, IoT Hub, Event Hub, Hub, Schnuggeberger Hub, all those hubs, right? All those things?
Well, they're all, right now, but it seems to me like they've changed it so that they're all the same implementation. Like IoT Hub is Event Hub, which is also what Service Bus is now. Like, it's just different layers of Event Hub under the covers. So I think it's all
Service Bus? No, Service Bus came way before those hubs.
I think they redid it.
You mean that those other hubs were developed on top of Service Bus?
No,
He's saying on top of Service Bus 2.0.
Service Bus, so that
So
they all
they-
have Azure Event Hub
Underneath.
as the engine underneath it.
Interesting. I did not know that.
Yeah, I think so. Don't quote me, but I think that's true. But to answer your question, there is a tutorial for Azure Databricks and Event Hub and IoT Hub. IoT Hub's Event Hub, but just a different interface.
Yeah, I can see that. That I can totally get. It's basically like the adapter pattern. Yeah.
Yeah, they talk about, basically they give you a connection string and you feed that connection string into
And by
So
connection string, you
configuration.
really mean, yeah, okay, I get it.
the URI.
Yes, URI, yes.
And so it's a pattern you're going to see. Like, it's actually the same thing with Kafka. You're going to import a library that is specific for event hubs or specific for Kafka. And when you're doing your Spark read stream, the format's going to be something that indicates, hey, I'm using this library that I've imported and then, configured.
Right. So to go
there's
back,
a lot of connections to it beyond kind of.
right.
what's called
So with that, so if you're talking
Event Hub can also
IoT,
be the sync too.
yes. But if you're talking like IoT, right, then this makes perfect sense why you'd have to scale out. Because now you're talking, okay,
500,000
I'm getting,
events firing.
500,000 events a second here, and there's no way that a single, node could be able to process those. With even if it's like count, I don't think it could keep up, right? Just the sheer amount of IO wouldn't be able to keep up, right? So it makes sense that it'd
I've
have
got
to
like
be.
10 video ideas just from the 45 minutes.
So
this Event Hub idea, both as the source and the sync, has a lot of merit.
Yeah, I mean, I think it depends on where you're switching on the smarts. Yeah,
Where you're
Smart.
switching
What
on
are
the
the smart?
sorry.
Because
So
GitHub is really dumb.
that's what I'm saying.
And so
Exactly.
you're saying,
So, but
Like, the
Spark
advantage of
is
Spark
is smart.
to say, hey,
Yeah,
give me the maps,
analyze. Yeah,
aggregate
yeah,
all
yeah,
this stuff, do
yeah.
this model.
yeah. Exactly.
Oh
But
shit,
then-
something bad happened. We're getting frauded.
Yeah,
defrauded, like
yeah.
publish that.
Yeah,
Tell
exactly.
everybody we're
Right,
gonna be
right.
frauded.
Yeah, but then if you're publishing a much smaller amount of things, then it probably doesn't need to go to
The
Event
example
Hub.
that
But
Jihan,
uh-huh.
is that his name? No, Cyprian
Oh yeah.
from Romania is
Yeah.
doing is they're getting like sonar feeds off of submarines coming over, and they lack the intelligence at the edge to detect mine or rock. And so they're just getting geographic spatial positions, and then they're running it through deep learning, and then they're saying, oh shit, mine. Like you're in a minefield, alert them back, they're in a minefield.
Yeah.
And he pulled a real data set where they were doing that, where they were just getting the geographic positions. And he's right now doing it. He's training it to say, these things were positive for mines. Like somebody saw it and said, that actually is a mine, right? So when you see patterns that look like what the human said was a mine, like assume mine.
What is it that Chris always said? What's the metric for machine learning? The area under the curve or something like that. It's the
ROC.
ROC, yeah. And so he was saying in certain situations, it's very important to, not have any false positives or not have any, false negatives or whatever. That would be a situation where I can think, like it's okay if you say that rock is a mine every once in a while, but you better not under any circumstances say that is wrong.
Yeah.
So Scott, to my earlier question, I reread this and I think I found the answer.
Yeah.
Question.
Okay, wait.
76.
376. Oh wait, we're not even there, man. Okay, but yeah.
So in
Go ahead.
in the Kindle, it's like a couple paragraphs before dropping duplicates in the string.
Dropping duplicates in a string. Okay.
So
At this point.
so in the middle of the page.
End mode, complete mode update.
No, we're not. We're going back.
Oh, but
to
this is
go ahead.
actually referencing that specifically. Okay, so it's saying that if we have a watermark of 30 minutes,
Yeah.
and we've got a window of 10 minutes, right? It says that structured streaming will wait 30 minutes after the final timestamp contained inside the 10-minute window before it finalizes the result of that window. And then depending on the mode, the next sentence says, I'm paraphrasing, but if you use complete mode, you can actually query and you can see the intermediate results and they will change over time within that 30 minutes.
Yeah.
But if you're using append mode, then this information won't be output until the window closes.
So we were both right.
So you're right. So in append mode,
Yeah.
you can tell Spark to run the instant it finishes a batch to start the next batch, and it could be doing batches every 10th second. That does you no good if your window's 30 minutes. You're just processing a bazillion micro batches, and they're all just sitting there in memory for 30
It
minutes.
still might be good though, if processing it heavier. Like it still might be good to process the small batches.
Yeah. What could happen
yeah,
to that? It's just a. I mean, what you're getting is just
and once
30
you hit,
delay.
Once you hit 30 minutes, you're gonna get.
Yeah, you're gonna get.
Right. But I'm
Yeah.
saying after you waited 30 minutes, does it really matter if you waited an extra 10 second or you waited 2 seconds?
Well,
if my streaming job is gonna be running as long as I can keep the damn thing running, then I might be cool with that.
Yeah.
Like, I need to have an update every second, and the first 30 minutes of startup, it's
interesting.
nothing's happening.
But it's still the case that the guy who's like charging the credit card that you say it's fraud. It's been 30
Well,
minutes since you
that
left
wouldn't
the
have a
store.
30-minute watermark, right?
You want like a minute.
This paragraph is this.
Wait, what? We're still in the same paragraph, or no?
It's a little bit later, but it's on topic.
Keep jumping ahead.
Okay.
We're in the same book.
Structured streaming limits your use of each mode to queries where it makes sense. For example, if your query just does a map operation, structured streaming will not allow complete mode because this would require it to remember all input records since the start of the job and rewrite the whole output table.
Yeah.
This requirement is bound to get prohibitively expensive as the job runs.
Yeah.
So it won't even let you do it. How is this?
Where does it say that?
That was actually back. Hold on.
It's still in the stateful process.
No, this is 348.
If your chosen
348.
node is not available,
Yeah.
Spark Streaming will throw an exception when you start your stream, meaning your action is incompatible with your output mode.
Okay, now that part was not in there. I lost you there, but
It's in
I
the,
think
so in the how data is output
It was- it is
mode
there.
section
It is
under
there.
the when can you use each mode?
And then he gives you a handy table and he says queries with aggregation. An aggregation
There's
on
another.
event time with watermark will support append, updated, complete.
So he's like further down. That's a
So, like-
different output mode section.
Queries with map groups with state
oh yeah,
only
yeah.
support update.
That is not that page. It's
Okay, but I'm
still
still reading
I
this
got it.
one.
I got it.
Okay, feel free.
Example account based on
He's reading
those.
it. That's all I'm telling you.
Thank you. I'm so confused.
But it applies. It is
No,
what
it
you're
does. It
talking
does. Yeah.
The fact that there's two sections on output mode.
Yeah, that's what it is. Okay.
He like comes back and like talks about it.
Yeah.
Interesting. This is a cool little table though.
Where the F is the table? Sorry, almost lost it there. Where is the table? What table?
So it's almost at the end of the
22?
chapter of 21.
21.
And there's like a when data is output.
363?
Right, 363. Let's see.
Ah.
Yes. So he was reading from right here. When can you use each mode? And then that table
Okay.
goes along with it.
Okay.
Did I go back or forward?
Who the F knows at this point? We've gone back, forward, left, right, up, down. I mean, I don't know. It's. I think you're fine.
So
I think you're
it's
looking
almost
forward.
like
We're in the structured streaming basics.
streaming
Yeah.
decisions. The streaming implementation is easy, but the decisions are difficult.
Yeah.
Okay, we've got the stream coming in. Like, what are we going to do? What's our watermark going to be?
Yeah.
What are we going to do with this data?
What happens if it's out
What
of
happens if
order?
it's out of order?
Mhm.
What happens when we need to stop it and restart it in a different cluster?
How
because
do we
something
catch
went
up?
wrong?
What happens if events come in late? What happens if they come in really late?
So
What happens if like a really important event comes in 4 hours late? Like, what do? We all have to make decisions on what to do.
And
So-
most
so-
of that is not at all tied to Spark, right? It's
Right.
like, no matter what streaming system you use, it's gonna be challenging.
So what I'm reading is if you say, I want Spark to aggregate the click count for each user, okay? And I use update mode.
Yeah.
All right. Then in our 10-1-2 example, okay, the 10 and the 2 come in and it says this user has 2 clicks. And it will output that, it will emit it. And if it's emitting it to whatever source, you can read from that source and it'll say, this person has 2 clicks.
Yeah.
Then when that half-hour delayed message comes in, it'll update it and it'll say, it's 3 clicks.
Yep.
And it's just sort of like, like in an RDBMS, when we talk about transaction isolation level, right? You could actually get
Dirty.
a dirty read
Mhm.
that's impossible from a serialized sequence of events to have actually been the intermediate state at any point in time.
Yeah.
Right? Or let's say it's not click count, let's say it's a summation,
So
right? So the numbers 1, 2, and 4 come in. Okay?
You missed the.
If it's serialized, it should be 1 and then 3 and then 7. But you could actually get a 5 because the 1 and the 4 came in before the 2 did. And at no point was the answer ever 5, but nevertheless, you're still saying it's 5. And ultimately, eventually, you'll all agree it's 7, eventually consistent.
Yeah. So who cares about the 5? That's the thing.
So in
You're going to
update
show
mode,
the best you know,
exactly.
and then
So
at a
it's
certain
in-
point in time, you're going to show whatever you're deciding is true.
Yeah.
You could be wrong then too, right?
Yeah. 'Cause there's always
But you hit your cutoff.
always that 30 minutes that
You
you
hit
still
your
don't know
cutoff.
about
This
yet.
is now truth. Yeah.
Right.
Yeah,
So
okay.
update mode is sort of like eventual consistency, and I'll just do what I can.
That's a good way to look
And
at
what
it.
you were saying, you can't do that funny thing where you just do one map on everything, because then you would for all of time need to know before.
Right.
If it were complete mode for a map on.
Right. Right.
So that's why if you're doing a click count or something like that, or a pen mode, or I don't know, whatever, but you can't use that mode because you would have to wait forever,
Right.
right? Or else you give it a watermark and then it knows, oh, okay, what we've been talking about, if your watermark's 30 minutes, and after 30 minutes, stuff's going to start flying out of it at, whatever fast increments, as fast as they were batching on the inside.
Okay, so now moving on to chapter 22.
Hold up. Hold up 1 second.
You said we do 22 and 23. Right?
I know, we're getting there. We're almost there. I wanted to highlight this section.
Oh, the table.
That and that table, which was 360. Where is it?
363. Did you already have it?
Yeah, that. Okay. So output mode is pretty important, is what we're getting at.
Yeah, it fundamentally defines the nature of the stream. Right?
Yeah. Okay. We skipped all over the place, but is there anything else we need to talk about before we move on to, wait a minute. This was 21, right? That we were
still
in?
Chapter 21.
Okay.
That table.
Now, chapter 22. Okay.
I have that news. I gotta go, guys.
So tumbling windows, sliding windows.
Just got back. Oh, he's jet lagged.
Okay. Bad news for us, not bad news for you.
Yeah.
Okay, good.
Exactly. Yeah.
I was like,
I'll see
this
you
is.
guys. Just we're gonna do machine learning section next time.
Yeah.
Good to see you guys. I'll see you next week. Next month.
Yeah.
So pick a date.
Oh yeah.
Will you guys pick a date?
Well, we're just gonna do the 4th. What day is today?
The 4th in August.
July,
It's
so
gonna
that'd be
be,
August.
Yeah.
August 27th. Okay.
August 27th.
Yeah.
Yeah, that's the only day it can be next week or next time.
The only way-
Only thing it
What
can
time
be.
you're available?
6:30 to 8:30.
Are you available?
Oh wait, let me check.
Yes, I think I am.
Okay.
It's
Pick a
27th.
date. Sorry to leave early.
August the 27th. Yes, totally fine.
Client in Minnesota, but I can call in for it.
All right. A lot of this stuff, actually, the windows on event time, it reminds me of TCP algorithms. It's how TCP works, right? So you can have nagling, you can have, it does a sliding window. Yeah, so it all seemed fairly straightforward to me, but was there anything that anybody has a question about?
Well, so I kind of fell behind on the reading, and I had to catch up, so I think I missed some stuff. Is the window distinct from the micro batching frequency, or are they the same thing? They're
No,
lockstep?
They're different. The micro batching is how often you're going to pick up new data. How often you're going to. What length of time you're going to batch data by? So if I want to batch data by in 1 second, batches. That's what that setting is.
So if I set my micro batch to be 1 second and my window to be 30 seconds, then that means my stream is going to be processing every second. But on my output stream, as it were, it's only going to output once every 30 seconds.
That's correct.
No, I thought it's
It's
gonna.
the window size.
Or window
rather-
size is how much data is going to be included in that final output.
Right. And that's what you're
I think
saying.
it's going to output every second, but for 30 seconds worth of data if you're doing it.
Well, it depends on what you're doing here,
Well, I guess it
right?
depends on your settings.
Yeah,
The
sliding
two
window.
examples they gave were non-overlapping and half-overlapping windows.
Right.
I
Yeah.
don't
So
know
if you
can
have
just do an
a
arbitrary,
overlapping window, then you are correct. If you have a non-overlapping window, Ted was correct, right?
What's a
So
non-overlapping window?
well, like if you're saying
like a window every minute.
yeah,
no
I
overlap.
want the biggest thing every minute,
Okay.
then it's only going to output one event a minute, right? Whereas if you're saying, I want a rolling average over the last minute, and your micro batch size is every second, you're going to get an output every second that's going to be the rolling average over the last minute, right?
Yeah.
So in that case, the window is overlapping. In Ted's case, the window was non-overlapping. That's, yeah.
Is there code for those examples in here?
There is. I'm trying to find it,
Yes.
although my page numbers will be useless.
Well, the sliding window code example is 374. Yeah.
I want to know what the code that they're talking about. So that might actually be it. Huh? Maybe I should try it. Well, next time I'll try and have that up too. Sliding window. This is in chapter 22, right?
Mm-hmm.
Windows on event time. Okay. Tumbling window.
Yeah, the sliding window is what.
Windows, what after that?
Okay, yeah, so it looks like they say an hour, but we're going to slide the window every 10 minutes. So you can have as many
Yeah.
overlaps as you want.
Exactly. You can have them like completely distinct. You go even
Oh, right. So it's
higher.
So
that would be
obviously-
interesting. I hadn't even thought about that. You could technically, I guess you could. So what you're talking
Oh,
about,
no. This says 10-minute windows every 5 minutes. They're only half over.
right? I'm saying, so you can have something that's almost fully overlapped, right?
Yeah. Yeah. So
And you can definitely have something that's partially overlapped, and then you can have something that is not overlapped, cojoined or
abutting
abutting.
whatever, I
Yeah,
don't
whatever
know
it is.
what
You
it
know,
was.
like
Touching.
touching. Exactly. But I wonder if you can do this. That would be like
You can't,
throwing
'cause it'd be
away.
a hole, yeah.
Yeah,
So
you'd be
that-
like
that's-
throwing away certain events.
that's
But I mean, like,
topological.
I don't know.
okay, so we're talking about the
Right.
window function within the group by and the options there.
So the code for
I'm
tumbling
with us
window.
now.
Yeah. So it's just your window intervals, right? That you're specifying, and that's
Output mode.
and whether it's overlapping or
Output
whether
mode
it's
then would affect how often.
yeah.
Right. So I wonder though if it would create like a lot of memory pressure if you said, I want a 10-minute window every 100 milliseconds. Because now you have, I don't know even what math is, you have 6,000 overlaps of windows. So basically every data needs to be copied 6,000 times, right?
Wait. Hold on. You just blew my mind with that thing because
Sorry.
I was thinking about it differently, and then you said that. And I'm like, wait a minute, maybe that is how it works. I was thinking you have a set of events that are building up, and then you're filtering, like you're like, okay, that window's expired. I can throw these away now.
So the windows are just delineations, not full
Yes,
copies of the data.
exactly.
Got it.
Yeah.
So then every 100 milliseconds you say, okay, time to start processing this chunk of stuff,
Yeah.
and then another 100 milliseconds. Okay, now let's process.
Yeah.
this chunk
Now
of
I can
stuff,
throw that one away.
and then if anything
then,
ages,
yeah,
then I can
I can
permanently
age
get
it
rid
out.
of it.
Yeah,
I'll
yeah.
never need it again.
Yeah.
Okay.
Once the
No, that
watermark.
makes more sense. So it's
Yeah.
not memory pressure. It's just
Well, I mean, it's still memory pressure, right? You have a certain amount of.
But I'm saying it's linear. It's not actually
Yeah.
6,000 fold.
No, yeah, it's not like, yeah, there's no duplicate data. No duplicate data. Yeah. In fact, dropping duplicates in a stream, you can tell it, if duplicates are coming in within a certain thing, then you can chuck them.
It's kind of interesting to see how the like architectural decision-making processes that they were able to make with Spark, because they were thinking we're primarily doing everything in memory. Like, there's cool stuff you can do with this streaming that would be harder if you didn't just have everything in memory. You know what I mean?
Right.
You'd be writing tons more code with like spooling, buffering, whatever,
Mhm,
and then your performance would degrade as soon as you need to use that, right?
Yeah.
Spark's basically saying, I'm going to keep everything in memory. If it doesn't fit in memory, I'm going to throw an out of memory exception, and I'm not going to actually worry about spooling or any of that.
Yep. Yep, that's true. Very, very good point. Okay. So then we have timeouts. Wait, hold on. So that means basically no event within some time. Is that the deal? I thought I actually read this. I did read this. I don't know. I must have just glossed over it. Okay, and then we get finally to our output modes, which were covered in the table. Okay. Okay, so that's basically the end of chapter 22. We are going to get through this because 23 is really short. And I actually didn't read 23. That's where I stopped. I have my bookmark right there. But you were saying, Dustin, this is the part that's like where it can get hairy.
I put it all in. We got into a lot of it there too, with how to set all that stuff up and what happened in the order. But so it's talking here. The key thing that I catch here is about checkpointing and making sure you are saving to file a durable file, the checkpoints, and able to, if your job just stops running, if your whole cluster goes down and you spin up a job with the same ID or with the same checkpoint, it can then pick up where it left off and continue along. All right, so if your job crashes an hour in, and you were waiting an hour to output the first thing, something like that.
Output.
Or you're waiting 30 minutes, whatever it is. Like, you don't want to have to start fresh and lose all that state you have. So checkpoints is a way to manage those kinds of recoveries.
Interesting.
So when they talk about the write ahead, they're talking about you're doing a write ahead on your inputs, your stream inputs, so that you have them in case you need to start over.
The write ahead. I'm
And
gonna
rebuild
read what
that state.
I saw the term right ahead.
Wait,
Not
what?
a term on there.
I missed that. Right
The
ahead.
very
Where's-
first page of chapter 20.
Okay. Right head.
Right, so it says use checkpointing and write ahead logs. I'm assuming the write ahead is it's either writing your input or the intermediate state, but it's basically saying I'm not writing this to the output. I'm just persisting all this stuff that I need in order to recreate.
Okay. Yeah. So write ahead logs would be basically writing as the events came in, right? Even though you may not be at a point that you can output something yet.
Yeah, you don't know what the output is. Your window hasn't.
Right.
closed.
And you would always want your checkpoint. No, I guess that's not true. But you would want your checkpoint less than the size of your output window, right? Like if you were saying if you have something where you don't output for an hour and you have your checkpoint, if you had your checkpoint at an hour and 10 minutes, that's completely useless, right?
I mean, how
Because-
frequently
I
you
don't
checkpoint?
think you can really manage the checkpoint. You're telling it a location,
And that's it.
and Spark's gonna.
I thought
manage
it said,
Maybe you can. I've never
oh, okay.
done much with it. What I have seen, and it was on Spark 2, but several like minor versions ago. But I don't know how often this pops up now. Is I'm trying to make an update to my streaming application, redeploy it, kick it off again, and it can't work with that same checkpoint file because that one was specific to the old code.
Oh,
And so
you've
trying to
updated.
avoid changing it in a way that you have to start from the beginning. A lot of times, to be honest, I was in a pretty dev mode and I didn't really care, but I had to go back and delete that checkpoint each time, so it would recreate it and start fresh. Otherwise, it would start running like the old code basically,
Yeah.
and nothing would make sense even though I changed my code. It was interesting. So I think it's improved some. I don't think it's it's always going to work, right? If you're changing your code, you're going to have to think about that.
So Scott, are you familiar with like how SQL Server does backups?
A little bit. Yeah.
So
Transaction log and versus full we were talking about or whatever.
right. So basically, the stuff that you've managed to persist to a table, you just copy that to the backup, and then you need all the transaction logs, right?
Mhm.
So you can basically think of the write-ahead logs as the transaction
Yeah.
logs.
Yeah.
And the checkpoint to contain all the state that you've already dealt with your input, right? But if you haven't dealt with the input yet, and in theory, if say your checkpoint itself took you 20 seconds, then from the time you started the checkpoint, you've now got 20 seconds worth of
Right.
inputs that have come in, and you're going to need to write ahead those until you get to your next checkpoint.
Yep.
I think that's
Makes sense. So do they talk about update your streaming application code? Do they mention? Yeah. With small adjustments like adding a new column or changing a UDF, they are not breaking changes and do not require a new checkpoint directory. There are larger changes that do require an entirely new checkpoint directory. Yeah. New aggregation key or fundamentally change the query itself. Yeah.
In my experience on Spark Pi 2.1, most changes require a new checkpoint directory.
Yeah.
So that's what I was caveating. But they do talk about Spark version changes.
Yeah.
It should be for, but that's not your application. That's actual changing Spark cluster.
But your scaling and resizing should not affect any of that stuff, right? No. Looks like no.
Yeah, I wouldn't expect it to.
Okay.
But your other performance tuning will, right? So when you go, oh, really, I need to repartition this because something's going on that Spark's not interpreting correctly. That's trickier.
Cool. I like it.
so. Have you ever
Streaming is cool.
thought about the idea of like, can I pause in some way my inputs so that I can flush out all the outputs so that I don't need my checkpoint and I can change my code and then I can just.
Yeah, so we typically had Kafka as the source. So we had a buffer, right? And so
Well, I guess
Well,
in your example where you're saying
I have
just
not
show me the
taken
max
a lot
from
of
the
advantage of
last
windowing.
10 minutes, ultimately you're just going to lose 10 minutes worth of.
what do you
Yeah.
and what do you do with that Mac? In that type of situation, it was probably like going onto some dashboard on a screen that was mostly vanity purposes. Versus if I'm processing each message or each batch and writing those out back to Kafka usually, which then would go to a database for longer term analytics. then there wasn't this need to like let the last 30 minutes play out before I finish it, right? So this piece where it can update itself within a window, that's not something I really took advantage of.
Just thinking like your example, like what do you do when you want to release that new build and it breaks this? You're essentially going to have to just kill your stream and start from scratch. You can't resume from where the old code was running, right?
No, I don't know if I agree with that. So you have a source of events and you spin up a new cluster which has the same source and same output place. I guess it depends on how it's done.
Modified code.
Yeah, with modified code. And then once the new one's up, you can shut the old one down. But
I don't think you can have the two of them writing to the same output.
Well, it depends on how they're writing the output.
There's a good chance you're going to get dupes in your handling. So you might. That was our most likely scenario. We're going to have a very short time where there's duplicates being written to the database because we already have to deal with them anyway.
Right. Better
something
in
in this whole pipeline has to be idempotent, and it was always downstream of us. And so we'd go, all right, so we got like 10 seconds of dupes or something, right? But not like 30 minutes.
Yeah.
Okay. So we usually wrote the code downstream that was dealing with the dupes too. So it wasn't exactly like we were kicking it down the road to ourselves. But
yeah, I mean,
that was easier than trying to handle dupes in the stream itself.
Yeah, you could use Kafka for the. That's what you guys use Kafka for, is like the buffering, deduplication. You know, like that way I can take things down and move things up, and you know, Kafka sort of dealing with it a little bit for us.
Because Kafka can not with the exactly one semantics.
Yeah,
though it was,
but it can
at least one semantic.
Yeah, well, it could.
Actually,
it could dedupe. Yeah, it could dedupe, right? Kafka, it's like
if everything end to end is set up correctly with how it's going to act and those kind of things, yes. But we were never the things I was the most in the loop on were not set up that way.
What would be interesting is because it talked about Spark as being able to dedupe. So what would be interesting, again, I'm going back to this like multiple Spark thing where you have a streaming job that's writing the statistics or whatever for your main job or whatever. But also if you're doing streaming job, you could have the output of your streaming job feeding to a deduping Spark, which feeds into your database. And then you could have, that way you could run, and deduping is so simple that you should never need to change it. And that way you can change your main one. You can write up to exactly the same Spark deduping and then bring up a new one. And now you're going to be deduping a lot, and then you shut down your old one and then it'll go back to normal again, right? You could kind of chain these things together so that,
The pattern I've used a couple different ways with the same concept was Kafka is the input, do our Spark processing. Basically, our streaming ETL is really the use case that fits best. Output back to Kafka, and then have a reader that writes it as an upsert to a relational database. And so if it comes in twice, you're just wasting a little bit of.
Oh, upsert. It would. Yeah, I get it.
If it comes in out of order, things start to get
wonky.
That's the thing you have to be a little more careful of. But if it comes in the same thing twice.
Yeah. Okay.
The other thing would be to write it to a file and then load it to a database. And then usually like Hadoop or Redshift or whatever would have the duplicates in your queries, or then grouping by every dang thing, which is not great. But if it's all part of ETL, then you just have to balance where you want to have the complexity.
Yep. Gotcha. Cool. And that's a wrap.
Yeah.
So next time we're doing advanced analytics and machine learning. Sounds fun.
The rest of the book.
Starting with 24.
Yeah, actually, we don't cover ecosystem, which is like this little chapter at the end, this tiny little, well, I guess it's 2 chapters.
So part 6 is 137 pages.
Yeah, it has to be done though.
Oh yeah, I'm really looking forward to it. Although I haven't peeked, so I don't know. Might if it's going to be a quick read or a heavy read.
Yeah, I mean, I think if you've got some exposure to machine learning, I don't think it'll be that bad. But if you're trying to start from scratch,
Right.
you've never heard any of these words before, it's going to be kind of painful.
My guess
I think
is it's going to be a light read.
Well, yeah, it's can't go into depth, obviously, if it's 137 pages about machine learning. You know, like you have, you know,
Right.
700
saying,
page
like-
textbooks about it
Like
as well.
there's this thing on standard scalar, right? You don't know machine learning, and you don't know what a standard scalar is. You're not going to have any idea what the standard scalar is. But it's going to be like, oh, well, you do this and you pass this parameter and it works. So like whatever the heck it is, that's what you do.
Yeah.
You know, it's kind of like that Spark SQL one. Like,
It's
you
Yeah.
do a join. Okay.
it's sort of a look how easy it is to build models, train models in
Yeah.
Spark. Like, cool. Now get the models accurate enough that you can detect mine. You're like, oh, where's that chapter?
Yeah, that's not going to be in, that's not going to be in here, right?
Well, I mean, but it seems to me basically like it says, if you want to do this, this is this. If you want to do that,
Yes.
If you want to do that, that's. And so
Take that, compare it to scikit-learn, and you kind of know which one fits better, and then understanding it.
But I'm saying this is almost like a reference. You know, like, oh, I need to do, you know, random forest and how do I input the cost matrix, right? And then it's like, here you go. This is the syntax for that. But if you don't know what those things are, then it's just gobbledygook in an index, in alphabetical order.
Yeah. Cool. What was the I could never remember what said, and I still can't remember what I had to give a talk about machine learning one time, and I had there it is. I was looking for that pencil. I had a note card that had this thing that I had looked at like right before the talk. I'm like, okay, I think it's smote. You know what smote is?
Oh.
Yeah, it's like basically if you have a disproportionate, let's say we're talking about fraud. The number of fraudulent transactions is disproportionately small compared to the non-fraudulent
Yes, so you have unbalanced
transactions.
data.
So you've way unbalanced data. And smote is a way of evening it up so that it doesn't guess that it's, you know,
it's not
that it's
fraudulent.
valid. Yeah, when it should be fraudulent, right?
So is that just a particular algorithm?
But it stands for something wickedly hard to say and remember. And
Because I know basically you can do upsampling and downsampling, and you can actually do a mix of upsampling and downsampling. So maybe smoke is a
synthetic minority oversampling technique. Synthetic minority oversampling. So it basically takes the small number of fraudulent cases and comes up with other fraudulent cases. Yeah, basically.
So it sounds like it's not just repeating them, but actually trying to create synthetic examples.
Yeah.
That are similar.
Yeah. Yeah, exactly.
I have not used
Smote. But every time I try and say what it stands for, I have to look it up. I can't, even if I had it in a card 15 seconds before I've been talking about it.